All right, let's get right into it. If you're building anything for the web, you're dealing with JSON. It's just a fact of life. And if you're using Postgres, you have this incredibly powerful tool called JSONB sitting right there waiting for you. But, using it right can be a little tricky. So in this explainer, we're going to pull back the curtain on JSONB and show you how to turn it from this kind of confusing feature into your absolute favorite tool for managing data. So here's the plan. We're going to start with a quick look at why JSON runs the world. Then we'll get to know JSONB itself, what it looks like and how to pull data out of it. Then, and this is a big one, we'll cover the single most common querying trap that gets everybody. After that, we'll see how to make your queries lightning fast, and we'll wrap things up by busting a huge myth about schemaless data.
So first things first, why are we even talking about this? Well, it really all boils down to the fact that JSON is, well, it's everywhere.
Yeah, this quote from Crunchy Data just nails it. JSON isn't just some option on the menu anymore. It's the language that different parts of the internet use to talk to each other. Think about APIs, config files, you name it. It's probably JSON. And that's exactly why having a smart, high-performance way to handle it right inside your database is such a massive game changer. Now, Postgres actually has two types for this, JSON and JSONB. We're going to focus just on JSONB. Why? Simple. Performance. Okay, so it takes a tiny fraction of a second longer to write data because Postgres is busy converting it into this super efficient binary format. But the payoff? Oh, it's huge. Your queries, your data processing, everything becomes way, way faster.
So what does the stuff actually look like when you store it in a column? The cool thing is, it's super flexible.
On the most basic level, you can have a simple object, key value pairs. If you've ever touched JavaScript or looked at an API response, this is going to feel right at home. It's instantly recognizable. But you're not locked into using objects. You can also store a simple list, an array, as the main thing in your column. This is perfect for stuff like tags on a blog post, a list of user permissions, really any kind of collection. And this is where the magic really happens. You can mix and match these things. You can nest objects inside of arrays, arrays inside of objects. You can go as deep as you need to. This lets you represent really complex data all inside a single searchable column in your database. It's awesome. Okay, so we've got all this cool, complex data stored. How in the world do we get specific pieces of it back out? Well, Postgres gives us two main ways to do it. First up, you've got operators. Think of these as your quick and dirty shortcuts for just grabbing a value from a key. They're simple, they're direct, and for a lot of basic tasks, they're perfect. But then you have JSON path. This is a full-on query language just for JSON. It's way more powerful and lets you do really complex searches and manipulations that the simple operators just can't handle. All right, I need you to lean in for this next part. I promise this will save you hours of banging your head against the wall. We are about to walk through the #1 trap that trips up almost every single developer when they first start querying JSONB data. Let's set up a realistic scenario. Imagine we have a systems access column, and it's a JSONB field that stores the last time a user logged into different systems. And our boss wants to know who's logged into the CRM in the last week. So your logical developer brain immediately thinks, okay, I'll just write a query like this. We use that operator to grab the value for the CRM key, and then we check if it's greater than a timestamp from 7 days ago. Seems totally logical, right? Nope, you run that query, and Postgres just throws this really confusing error back in your face. It's complaining that it can't compare text to a numeric value. And you're sitting there thinking, wait a second, I stored a number. Why does it think it's text? This, my friends, is the trap. So here's the secret. It all comes down to the difference between two little arrows. The single arrow operator, arrow, gets the value, but it gives it back to you still wrapped up as JSONB. It's like it hands you a locked box. But the double arrow operator, arrow, arrow, that one opens the box and gives you what's inside as plain text. And that's why our query failed. We were trying to compare the text 12345 to the number 12345. And once you understand that, the fix is almost laughably simple. You use the double arrow to get the value out as text, and then you just tell Postgres what kind of data it really is. You explicitly cast it to a float using :float. Just like that, Postgres knows it's comparing a number to a number, and your query works perfectly. Okay, so we've made our queries correct. That's a huge step. But correct isn't always fast, is it? So now let's talk about how to make these queries fly. And just like anything else in databases, the magic word is indexing.
You've basically got two main weapons here. A B-tree index is your sniper rifle. You use it when you know you're always going to be looking up the value of one specific key, just like our CRM example. It is incredibly fast for that one job. A GIN index, on the other hand, is more like a searchlight. You use it when you need to find rows that contain a certain key or have a specific value somewhere inside the JSON. It's perfect for more exploratory kinds of queries.
All right, for our last point, let's zoom out and talk about a big picture idea that causes a lot of confusion when people start using JSON in their database.
I love this quote because it just cuts right through the marketing hype. This whole idea that when you use JSON, you suddenly have no schema or no data structure, it's just plain wrong. It's a myth. Think about it. Your application code absolutely has expectations about what that data should look like, right? It expects a name key to have a string or an items key to be an array. There's always a structure. The only thing that's changed by using JSONB is where you enforce the rules of that structure. Instead of the database doing it, that responsibility now shifts over to your application code. And that's the big idea I want to leave you with. Using JSONB is a powerful choice. It gives you amazing flexibility, but it's an architectural decision. The question you should always be asking yourself isn't if you have a schema. You always do. The real question is, what part of my system is the right place to define and enforce it?